Okay. This question requires us to use everything that we had on the diagram, right? So, area of TB that's TB cubed. That's the triangle. Okay? And then we have got PQR. Okay? PQR. So PQR is PQR. Now, to make things easier for myself, let me just label it based on the constants. Okay? Because that is going to help me a lot to get on. Okay? So this one we called it 2y, that was 3y. And like in terms of x, this is 3x and that's 2x. Right? In terms of k, obviously it's 3 over 5. It's 3 over 5k. And this was 2k. This is 3 over 5k. Okay. Then, now those two triangles, I'm sure you can see that we have got TQB. This is TQB. Okay? And we have got PQR. They share a common vertex, but do they have a common height? Do they have a common height? No. They share a common vertex, but they don't have a common height because their bases are not on the same strata. What that means is, if I try to use our base times height directly as it is, it won't work. If I try to use the area rule, they don't have a common angle. So what that means is, I need to identify a third triangle that shares a height and it shares a height, both of them. Okay? It shares, or I would say it shares a common height with both of them. Okay? So let's look at TQB. TQB. Which triangle, okay, shares a common height with TQB? I'm talking about a triangle that we probably might know some dimension of it. It's what? WQZ. PQV. Yes. PQV, yes. Okay. PQV and TQV, they share a common height because they have a common vertex here. Therefore, they share a common what? A common height. Once we identify that third triangle, does it also share a common height with the PQR?
Yes.
Yes. Then we are done with the question. So what you do, this is what you do now. I'm going to write it in full for you so that you can understand. So it will be area of triangle TQB over area of triangle PQR is equal to. Now here you have to use a mathematical technique such that when you multiply the areas, you come up with this. So I want you to be aware that this is equivalent to, check this out, it's going to be equivalent to the triangle that we say is common. That is what? PQ what R is going to be equal to the area of triangle, we say PQV all over this denominator, which is the area of triangle PQR times, I'm using my knowledge of fractions, times the area of TQB, area of TQB of triangle TQV over the area of triangle PQ. It will be PQV. The reason why we do it this way is because, I hope you can agree with me. Just give me a second, I need to recalibrate it. Okay, check this. You agree with me that based on the product that I wrote on the right, this numerator and that denominator are the same. So they cancel out in one base. Okay? But for our question, we cannot cancel them out. We need their dimensions for us to carry on. So, how would you find the area of PQV? We use the dimensions that we know. Alright, I need you to be aware that for the length of Q, for QV, I can use another letter. So I've got Y, I've got X, I've got K. Let's use M. So this will be 2M. Okay, let me recalibrate. So I'll say this is 2M. Okay? It's 2M because in triangle QTV, if I use the proportion theorem, because the coefficient of the K is 2, the coefficient of that M must be 2. The coefficient of the TW then in terms of K, okay, in terms of K is 3K over 5. So here it has to be 3M over 5. Okay? The coefficient of the constant must be the same. But the constant is a letter. So let me substitute now in terms of the constant. The area of PQV is gonna be in terms of K. Okay? Remember, it's gonna be in terms of what? Of K. It's gonna be half. Okay? Remember, it shares the common height with the triangle PQR. Do you agree with me on that? They share a common height. So the ratio of their areas will be equal to the ratio of their bases. Right? So in actual fact, I don't need the constant. All I need is that the, the base of PQV is going to be equal to 2y. So I put 2y here. The base of PR is going to be 2y plus 3y, which is what? 5y. If I wrote, that's 4. But before I carry on, I want someone to ask questions. I want someone to ask before I carry on why I wrote 2y over 5y. It's because these two triangles, they share a common vertex, which is this one. Okay? They share a common vertex. Remember, we have got P, Q, V, and P, Q, R. So you know your rates of. I think we did probably. Yeah, we did. Right? But let me write it this way. Times the area of TQV over area of PQV. Remember, TQV and PQV, they also share a common what? Common height. Therefore, the ratio of their areas will be equal to the ratio of their bases. Make sure you know that. I think I told you that the other day. That if two triangles share a common vertex, if their bases are on the same straight line, it means that the ratio of their areas will be equal to the ratio of their bases. I spoke about maybe on day 1, day 2, somewhere, but I spoke about this. Okay? So the area of TQV, remember, is T, can you do me a favor and look here? TQV, okay? TQV. And then we also have PQV, that's PQV. They share a common vertex. Which one is the vertex that they share, which we can consider? It will be this one here, not that one. Okay? Because we want them to have a common height. So we choose this vertex here. You follow what I'm saying? Yes. So if we choose this vertex here, means those two triangles are going to share a common height, and that height is going to look like this. They are not right angled triangles, so it will be, you can draw it like that. That will be the common height, this length here. Okay? Then, once I have that, then the base of those two triangles, for PQ, for TQV, that is TQV, its base will be what? I expect you to look here, because the diagram is not on TQ. It will be TQ. Thank you. You see that? Okay, let me warn you, if you miss that, this question here, you'll never be able to understand what's going on. Okay? The two triangles share a common vertex. Okay? And their bases are on the same straight line. Therefore, the ratio of their areas will equal the ratio of their bases. But if I ask you to draw or construct where the height is, this will be the height. I hope you are aware that if I give you a triangle like this, and I ask you to say, construct the height you construct it outside the triangle. Like that. That's what I do. And the height is always perpendicular to the base. So this height is perpendicular to PQ, therefore it's also perpendicular to TQ. So thank you, Taongo. So it will be TQ. But our TQ now, we need to write it in terms of K, because QW is 2K, TW is 3X, it's also equal to 3K over 5. So I have to add 3K over 5 and that 2K. So I can write that as 2, it will be 2 plus 3K over 5, so it will be 2 and 3K, so 3 over 5K, like this. I can simplify this and write as 13 over 5K. Just help me, I'm going to do that. So it will be 13 over 5K divided by the area of PQV, okay, is now PQV now. It will be the length of P what? PK. Do you agree with me that the base? Do you agree with me? It will be what? PQ, which is equal to K plus 2K, which is what? 3K. So I'll put here 3K. Then start smiling. The K and the K cancel. Y and the Y cancel. Okay? Then you are left with fractions. So 2 times 13 over 5 will give me 26 over 5. So on the next page, I'm going to write this is equal to 26 over 5. That's all over 5 times 3, which is 15. Then I'll remove the division line, introduce the division sign, so it will be 26 over 5 divided by 15 over 1, and that will be equal to 26 over 5 times 1 over 15. Okay, so the final answer will be 26 over 75. Okay, yeah, it's a level 4 question like this. So TQD over PQ1. It's a level of focus. Okay.